Okay, so we are now doing chapter 14 on static electricity. As mentioned, this is a relatively fast and short chapter that we're going to go through. I'm going to go through some of the key points in this chapter that a lot of people tend to have a common mistake about. Okay, so we're going to start off. Let's go on to static electricity. Okay, so in this chapter, we're going to learn what are electric charges, how do the charges behave, and what is an electric field. So these are the three main things that we're going to cover for today that we're going to look into more details about. So let's start off first, right? Electrostatics. So in terms of electrostatics wise, what we're going to do is this. Okay, first we're going to state that there are positive and negative charges, and charges are measured in what we call coulomb. Okay, so measured in coulomb, and still like charges repel and unlike charges attract. So these are the two main things we'll be covering in 14.1. Right, so we are looking through this part here. I think go to the basics. What are electric charges? So it's actually going down all the way down to your sorry, please wait for a while. Please wait. Okay, so in terms of the electric charges, the basics really goes down all the way back to the atoms. So the atoms actually consist of protons, electrons, and also neutrons. So the two main particles, okay, that contain charges are actually your protons. So this is positively charged, and the next one is the electrons here. They are negatively charged. So these two particles are the ones that actually allows your atoms to have charges. But generally, atoms they are not charged. Okay, why? Because atoms have equal number of electrons and protons, and since the number of protons and electrons are equal, we say that they are electrically balanced. They're electrically balanced. In chemistry, this is actually a term used. You will see the word electrically neutral, or electrically neutral. So just take note of the term here, electrically neutral. This is the term that we use in chemistry. But in physics, just take note that we will say that equal number of protons and electrons means that it's electrically neutral. So, yeah, it is neither positively charged or negatively charged. It's neutral. However, what's happening is that we can actually make an atom become charged. I say, we can make an atom become charged. Right? We can make an atom become charged. So how do we make it become charged? We make the electrons and protons become not equal. Okay, so to make the electrons and protons become not equal, there are two ways of doing it. One, we remove the electrons. Second way, we add the electrons. Now, when we remove electrons, the atom becomes positively charged because I remove negative charge. So overall, the atom has more protons than electrons. Right? More P than E. Right? That's why it's positively charged. If electrons are added, what's going to happen is that there is lesser P, there's more E than P. Right? More electrons than protons. So, key idea after reading through all this, okay, is that only electrons are added or removed. Okay, again, only electrons are added or removed. So the key point here of all the things that I mentioned is actually the idea of how do atoms become charged is only when electrons are added or removed. Now, do take note, protons are not added or removed. Okay, it's only the electrons. So I need you to think of this. Okay, so if in a question they say, an item or a substance or an object become charged. Okay, so for example, if an object becomes positively charged, okay, why is it so? How does it become positively charged? Okay, object become positively charged, what happens? This one happens is because electrons are removed. Okay, so when object become positively charged, what happens then? What happens is actually the electrons are being removed. So obviously the opposite part will also come true. How do an object become negatively charged? Okay, this is when electrons are added. So you realize that when something becomes positive or negatively charged, we don't talk about the protons at all. The focus is really on the electrons, whether it's being added or removed. So in electrostatics, this whole first part that is being mentioned here, we are really looking at how do something become positive and negatively charged. It is due to the electrons being added or removed. Okay, next one. Now, how do positive and negative charge interact? So I need you to take note here. The interaction is like charges repel, unlike charges attract. So this statement here, I need you to remember and to quote it. Okay, what do I mean and to quote it? So for example, if due to charges, two objects are attracted to one another, we need to say unlike charges attract. I need to remember the phrase. Okay, it's three-word phrase over here. Okay, because this two phrases here will help you. Okay, are important concepts that you need to state in explanation. Okay, so now what do we mean by like charges repel? So if I got if a positive object, when I put them together, it will face repulsion. It means they'll push each other away. If I got two negative object here, put them close to each other, they will repel also. So key idea, like charges repel. But when I have one negative, one positive charge being brought close to one another, okay, what I'm going to get is unlike charges attracting. So key idea that we have here is like charges repel. So two positive bring together, repel. Two negative brought together, repel. But if one positive, one negative, if I bring together, it will attract. Okay, so this is the first part here. Now, the third part we're going to have is about measuring electric charge. So charges are measured in coulombs. Okay, this is actually the key idea I need you to remember. Electric charge is measured in coulomb. Why is this important? Because you're going to need this in chapter 15. Okay, chapter 15, you're going to be toying with the idea of charges. Okay, so do take note, electric charge. Okay, we actually measure it in terms of coulombs. But all the various details here, you can read up on it. Okay, seldom that is being tested on this kind of minute calculations. Okay, maybe pure would have, but for combined science, we don't really go into such nitty-gritty details. But if you read it, it's actually quite simple because it's really about common sense. Okay, so it's about proportion, about common sense over here. Okay, so what are the key ideas that we have from 14.1? First thing, two types of electric charge, positive charges, negative charges. To make something positive, I remove electrons. To make something negative, I actually add electrons. Okay? So, to make positive charges, actually sorry, maybe shouldn't write like that. Let me rephrase it. There are two types of electric charges, positive and negative. To make object positively charged, okay, what do? You remove electrons. To make objects negatively charged, okay, you actually add electrons. So just take note of this. Next key idea that we have gone through is like charges repel, unlike charges attract. As I mentioned, do take note, you need to quote this in explanation. Okay, that means you must write down this particular sentence whenever you are explaining electrostatics, okay, in terms of attraction and repulsion. The last one, electric charges is measured in coulombs. We will cover this more in details in chapter 15. Okay, so this is for the first part. Now let's go on the next one, which is on the idea of electric field. So this one you need to take note of a few things, which is on the idea of definition, and also you must also know how to draw. Okay, now so in 14.2 what we're going to cover, we're going to state what electric field is, and we're going to draw electric field patterns. So electric field, okay, so let's look at this part here. Consider a single charge Q1. If another charge Q2 is placed near Q1, right, if both are positive charge, they repel. If one positive, one negative, they are going to attract. So this force of repulsion, this force of attraction, we call them electric force. Right, saying the force experienced by the charges is repel or attract, we call it electric force. Okay, and do take note, the two charges are not touching one another, but yet they experience that force, and hence electric force is what we term as a non-contact force. Okay, it's a non-contact force, right, because the force is experienced even when the charge is not in contact with one another. Okay, so the region in which the charge experiences a force forms an electric field around the charge. So in terms of definition wise, okay, it's actually over here. So electric force is attractive or repulsive force that electric charges exert on one another. Okay, electric field is a region, because it's a field, that's why it's a region in which an electric charge experiences an electric force. So if you put an electric charge in an electric field, it will experience an electric force. So definition wise, electric force I don't come out, but this one, yes. Alright, so this one I need to take note, know how to define what is an electric field. So how to represent electric field? Okay, we actually illustrate it with lines and arrowheads. So if I got a positive charge, a single positive charge, you realize I'll draw straight lines out in the 8 general directions, up, down, left, right, diagonals. Okay, these are the few lines. Same thing, the few lines over here. But what you realize is that for a positive charge, the lines are pointing out. So for positive, the few lines for positive, comma, the few lines, arrows, points outwards. Okay, for negative, okay, so this is positive, this is negative. Okay, the few line arrows points inwards. Okay, so positive you point outwards, negative you point inwards. Okay, so the lines actually is what we call the electric field lines. Okay, and the arrowheads indicates the direction of the electric field. So outwards is the direction of electric field for positive, inwards is the direction for negative. Okay, now these two I can safely tell you don't need to memorize. Okay, don't need to memorize. The one that I need you to really just take note of is this one here. Okay, the strength of an electric field is indicated by how close the field lines are to one another. So what is this talking about? So let's just compare this. Okay, I'm going to draw the electric field lines for these two charges over here. Okay, I got a single positive charge. Imagine I got double positive charge. What are the differences between these two field lines if you look at it carefully? If you look at it carefully, you realize, why you draw so many lines for the double positive charge one? How come so many lines? It's because if I have a double positive here, the strength will be greater. And then how do I indicate that the strength is greater is that I show that the field lines are closer. So you realize by drawing more lines, I'm actually making the field lines becoming closer to one another. So based on my two drawings, you can see that this one, field strength, right, the electric field strength, is stronger here. Right, stronger for this one. Okay, so that's for showing the idea of electric field strength by having the lines closer, okay? Closer. More doesn't mean stronger. Actually, the key thing that shows that it's stronger is by having the lines being closer to one another. Okay? So that's how you're going to draw the electric field strength in terms of the basic wise. Out for positive, in for negative. Secondly, if the few lines are closer to one another, it means the strength is stronger. So those two are the basics, right? How the arrows, how to draw, and in terms of the lines, the closeness determines the strength. As such, okay, this one, I need you to go and remember it, learn how to draw the few lines. Okay, so if I got a single positive charge and single negative charge brought close to one another, these are the few line patterns I need to draw. Okay, these are the few line patterns I need to draw. Okay, so in general, because they're going to attract to one another, so the few lines are connecting to one another. Next thing, I need to take note, because this is negative, this is positive, so you realize all the arrowheads are pointing away from the positive, all the arrowheads are pointing into the negative. So there's two parts to the whole thing. One is the pattern of the few lines. Second thing is the direction of the few lines. So you must be able to decipher these two, or you must be able to understand how to draw these two. So most of you just memorize the whole thing together, but my suggestion is don't memorize the whole thing. Think of it as two parts to it. What is the pattern like? What is the direction like? Okay, two parts of the whole thing. So actually, if you look at the whole thing here, I can actually split the diagram up into three main segments. Segment 1, segment 2, segment 3. So you realize segment 1, the lines are curving out. Segment 2, it forms this very nice connecting oval lines that connects to the negative side, and it forms a very nice oval and circular shape here. The middle part is a straight line. The third segment here, everything is curving in. Okay, one thing you need to realize is that the middle line, there is a pattern here, all of them is always straight. Okay, so if you're able to draw this diagram out, okay, actually you're more or less quite safe already. Okay, the arrowheads, as I mentioned, positive is out, negative is point in. So that's the general pattern that you will tend to see in such diagrams. Okay, this is for attraction, this is for positive and negative together. Now, this one over here is a positive plate and a negative plate. So this is positive plate, negative plate. The one at the top here is a positive charge and a negative charge. So it's quite different, charge, the drawing, versus the two plates, the drawings are very different. So the plates drawing in the middle of the two plates is all straight lines. By the two ends, it's a curve like this. So this is what you need to learn how to draw. Now the last part here is the idea of repulsion. So there are two positive or two negative charges. Our face repulsion, what you realize about the lines is that they will not touch. But the patterns is sort of like they will try to siam one another, they'll try to avoid one another. Right, so you look at it, the lines will not touch one another, they will always try to siam. Right, they always try not to connect to one another. So for the repulsion waves, okay, so we'll learn to draw this. You realize it's a mirror image. So if you can draw the left side, you confirm can draw the right side. Same thing. If you can draw the left side, you confirm also can draw the right side. The key point here still stays the same in terms of the direction. Positive is outwards, negative is inwards. Okay, so you realize the key idea that we have picked up on the previous page about the direction of the few lines doesn't change. So how many types of diagrams do you need to really remember? One is this one. Learn how to draw the attraction for two charges, their opposite charges, one positive, one negative. Learn how to draw this pattern. The second one you need to remember is this one over here. If I got two plates, one positive, one negative, how would the diagram, the electric field lines look? The last one these two diagrams are actually the same thing, except one is negative, one is positive. If you can draw one of them, you can definitely draw the other. Okay, so actually there are three main ones to draw. My key suggestion for you is go and practice this tree. If you ever remember this tree, these marks are actually simple marks for you to get during the exams. Okay, so what did we go through just now here? We actually learned that electric field is a region in which an electric charge experiences an electric force. So the field is a region in which that I will know that the charge will experience electric force. Next one, the direction of the electric field is the direction of the force acting on the small positive charge placed in the field. So all these lines here all these lines here with the direction arrow actually shows how it will interact with a positive charge. Okay, so that's what this is indicating here. But key point here, I want to highlight is that positive, it will point outwards. Negative, it will point inwards. Okay, so this is the for this chapter over here. Actually, we are at the end already, but I think I'd like to allow us to really look at this one, the test yourself 14.2. Okay, you might want to go about drawing these two, and even possibly looking at two positive charges or two negative charges placed close to each other. Okay, so you can try sketching this tree. If I were to sketch this tree, I think you're more or less a lot safer already in terms of getting to understand what you need to remember for this chapter. Okay. Yeah, so actually that's all for this chapter. In terms of map it wise, what did we really cover? So static electricity, we talk about static charges. So it's just generally charges. Okay, it can be categorized into positive and negative charge. And when you put them together, like charges will repel, and like charges will attract. And when you put them together also, you actually set up this idea of electric fields. Okay, and you can actually represent it by this idea of electric field lines. Okay, when the lines are pointing away, it's positive charge. When the lines are pointing towards, it's negative charge. Okay, so that's all for this chapter. Okay.